Okay, these are the 1.5 day 1 notes. The 2 days of 1.5 are all solving. So you can basically take pretty much any solving method you had in Algebra 2 and put them all together in the next 2 days, and that's what we're going to be talking about. And some of the stuff we're going to do, again, while we're technically in the review chapter, you may not feel like some of these things are review, but you didn't see them in Algebra 2, and that's very well possible, but the underlying concepts are there. So when we say review, sometimes we're saying the underlying algebra is definitely in the problem, but we've ramped it up a tiny bit to give you that pre-calc feel, get you guys kind of thinking about what makes the problem more difficult, what makes me have to think more, that kind of stuff. So here's sort of a short list of methods. This is going to be a fairly short video compared to the 1, 2, 1, 4 material. We're going to run because we're doing half today, half another day. Linear, so Algebra 1 style solving. So just like remembering some basic Algebra 1 process. Solving by factoring, eliminating fractions in rational equations, how you deal with that. And then what's called isolating the variable. Isolating the variable can be used in lots of different kinds of problems, particularly in solving some of our more complicated word problems. We may ask you to isolate a certain variable and solve for it. So we're going to run through some examples. Like I said, kind of short. I want you guys to take a look at the first example and just see if you can figure out what you might do to get that one going. Typically when I ask students about this one, we usually get a couple different ways of doing it. So just take a second, pause the video maybe, or just keep the video running and think about it. And I'm going to keep talking about it. One of the ways people would do it is they would say, well, I'm going to get my x's together on one side, which is a totally legitimate way to do it. That's an algebra concept, right? Get my x's on one side, number on the other. So I subtract 4 to the right, I move 5x over 12 to the left, and then I get those two fractions together with a common denominator. I would say no problem with that idea. Definitely is going to work. Another way to do it that some students will choose is just like right away, let's get rid of the fractions, which kind of is my preference. Just eliminate the fractions in the problem all one shot as your first step. That would be multiplying through by the common denominator. So it kind of depends on sort of when you want to do what with the problem. If you get both fractions together on one side and get a common denominator, you will have to multiply through by the common denominator at some point to get rid of the fraction. So you're just doing it later. If you do it right away, you basically turn it kind of into a basic Algebra 1 problem. So some of these things are kind of personal preference. My personal preference would be just multiply through by the common denominator, get rid of your fractions. So multiply through by 12, right? And then as you go, so 12 over 2, 6x, 12 times 4, 48, 12 over 12, gone, 5x. And then just do your little bit of solving to finish it off. Not much to that one. Now the reason I kind of push you guys a little bit towards that method is thinking about a problem like number 2. In this case, it makes more sense to multiply through by root 5 and get rid of your roots, which at the same time gets rid of your fraction. It also would be a good idea to think about a simplified root right in this area. So we'd say, well, this is actually really 3 root 5. Now think about it as multiplying through by the common denominator, which is root 5. What's nice about that is you're going to get rid of roots and fractions as you go. So here I'm going to have 5x, 15, and x minus 8. Now to be clear about what I'm doing with the roots, right? When I multiply a like root 5 times root 5, that becomes 5. That's essentially really the square root of 25. That's what's going on there. Same thing happens in the second one. Root 5 times root 5 is 5, then times by 3, and then of course I get rid of my fraction. And what's nice about the first couple is I get them in one step, I get them down to some pretty basic Algebra 1 style problems, and then just finish off the algebra. Okay, so the idea there is get rid of your fraction, and then the second one, get rid of your fraction and your root at the same time. Again, trying to be as efficient and effective as we can. Let's try some other methods, other problems. So in Algebra 2, one of the things that I always kind of try to drill on my kids on is recognizing when it is that I'm going to be factoring. When you get to a certain point in a problem where you see x squared, x, and number, regardless of where they're located in the equation, it should be driving you to factor, at least try to factor. Again, you may not be able to factor, and then we've got other methods, but at least I would try it. So when I see a combination of x squared, x number, my first thought is get everything on one side equal to 0. And see if I can factor. Now, in this instance, if it does factor, your choices are so limited that it shouldn't take you very long to figure out what you're going to do here. 2x can only be 2 and 1. And that's a matter of, is it 3 and 1 and 1 and 3, and does either one of those even work? It does work. go 3 and 1 and go all positive, that's going to be a 6 and a 1. Outside, inside, there's your 7x. And then don't forget your solving. Also, at a pre-calc sort of level of thinking, we want you guys to be able to just do things kind of quickly, and like I said, quickly, efficiently, effectively, however you want to talk about. I'll be using those words like all the time with you guys. You factor and you go to your solutions, and you can do all that in just a matter of like 30 seconds. You can finish that problem. If you're not able to do it that quickly, then that's like you're rusty, right? Do I remember my factoring? Do I remember how to deal with the combinations? I just would call it sort of trial and error, or run the numbers in your head, or whatever. Shouldn't really take any special methods to do some basic factoring. When you go to example number 4, it may not appear as a factoring question, but if you kind of look at it a little more closely, clearly you got an x squared in there. So we'll start with the cleanup aspect of it. And then again, we're checking for factoring. Now, I'm saying checking for factoring. Of course, the instructions here say, or one of the methods in the list I had was solving by factoring. So we're kind of saying, yeah, these are going to factor. There is, of course, a possibility they don't. We'll get to those methods on day 2. But what do you do with quadratics when you can't factor? And as a question to you guys, think about what your other methods would be. We'll hit those tomorrow. Now, as you're sitting there looking at the problem or watching me do the work, trying to figure out how did I get that, and I paused for a second there, right? I just didn't like crank it out like I did the first one. I paused for a second, and what I was doing was run the numbers in my head, and I'm going to just check for a second. Inside 14, outside 9. If the right signs, I'm going to get -5 out of that, so we're going to go negative, positive. And that's something that I would expect you guys to be able to do. Like, like I pause for a second, you might pause for a second, run the numbers, right? But we're at a high enough level of math now that it shouldn't take us too long to be able to get some factoring going on just by looking at it. Right? We don't need special methods and boxes and X's, and right? We just looked at it and we got it. Okay. Now, again, as kind of a reaction type thing, a lot of times I like you guys to look at the problem and just have an initial reaction. Like when I'm back here, and I see that first problem, I hope your reaction is, yeah, I'm going to factor. You look at this problem, and again, what's your reaction? Hopefully, you just think to yourself, I'm looking at a proportion, and if I remember the idea of solving a proportion, which goes back probably Algebra 1 or pre-algebra, the method is what? And that's all I really need to do to get going on this one. It's cross multiply. And then I see x squared x in number, right? So now I'm thinking, all right, I got x squared x in number. Probably I should see if it's going to factor, get everything on one side, go from there. At least when your lead coefficient is prime, you'll actually cut down your choices. And that's a matter of, again, where are things going to make it work out. Looks like outside -10, inside +3, there's your -7. Then again, solve your factors. Now, the other thing, too, is you're working with a rational equation. And when you're solving a rational equation, you need to check, do your solutions work? Which means, do they cause any domain restrictions or not? If they don't cause domain restrictions, they're good. But you got to check. And that takes literally a couple seconds. You plug your two solutions into either one of the denominators, as long as neither one of them causes a division by 0 problem, then you're good to go. And these don't. So you're good. But with rational equations, you got to remember that may happen, it could happen, and so I want to check and make sure. Okay, now kind of a similar problem, but I wouldn't say it's a cross multiply right up front. Same kind of question I asked you guys with the other problems. How do you think you're going to do it? I could see you going a couple different ways. Some people will actually move the 4x over x plus 3 to the other side, put them together with a common denominator, and then cross multiply. And that actually would totally be okay, right? As far as the amount of work you're going to do doing that, I don't think there would be much more work than another method. But I'm thinking back to the first couple examples, when I had a kind of this list of terms and I had fractions and I just want to get rid of my fractions. The easiest way to just get rid of your fractions is multiply 3 by the common denominator. Now in this case, your common denominator is an algebraic expression, not a number, but it shouldn't change the way you do it. When problems sort of look more complex, what I always want you guys to do is try to think about it as a simpler problem. If I was just working with a bunch of numbers down there in the denominator, and I just multiply through by a common denominator, it would get rid of your fraction. So why not do the same thing here? Question is, what is the common denominator, which would be x plus 3, x minus 3. And also, to cut out some work as you do this, right, simplify as you go. What I mean by that is multiply and cancel as you go. So in the first round here, the x minus 3's would cancel. You'd have 6 times x plus 3, that's 6x plus 18. In the second round, the entire denominator would cancel because x squared minus 9 is x plus 3 x minus 3. In the third round, or second round, the third round of multiplying, the x plus 3's would cancel, and you'd have negative 4x times x minus 3. So that'd be negative 4x squared plus 12x. This one is the one to watch out for because what you're going to miss, it just happens, it just is a kind of just natural mistake for a lot of math students is there's the negative there, which is subtraction, but it's got to be applied as a negative. So when I go to do this, negative 4x times x minus 3. Okay, so negative 4x squared positive 12x. You got to keep reminding yourself that that subtraction really has to be distributed. Okay, you get that far, then you're kind of home free now. So I look at, and I see x squared, x in number again, so my brain should train to, probably it's going to go to a factoring question. Everything on one side equal to 0, so I'll start cleaning some stuff up. So I'll subtract the 6x over to the other side, subtract the 18 to the other side, combine the x squared terms together, and then because I can, I'm going to divide through by 2 and make this a little bit nicer. Totally legitimate thing to do because of what I'm doing to one side of the equation, I'm doing to the other. So dividing through by 2, divide both sides by 2, however you want to look at it, perfectly okay thing to do. And then again, I'm checking for factoring. Looks like we're good to go again. We're going to go positive 6, negative 3 for a positive 3. And as a reminder, make sure you check your solutions. In this case, 3 halves, no problem, but negative 3 actually causes division by 0 right in here. It also causes division by 0 right in here. So with rational expressions, or equations, I should say, you have to check your solutions. So you notice really the theme here, actually, besides the problem starting different, is a lot of factoring. So if you're someone who's starting a little bit with factoring, you're going to have to really brush up on that to be able to get through these problems. Okay, last one here, and then we'll wrap it up. Just a single video today. Solve for L. So this is under the category of isolating the variable. And when you're talking about isolating the variable, it's to get it by itself on one side. And you can sit here and play around with this and do all kinds of stuff. But you want to, again, be quick and efficient about it. If you're solving for L, which means we need to ... When I'm done, this has to read an L equals expression. Best thing to do is get your L's together. So what I'm going to do is subtract 2WH to the other side. We have two terms that have L in them together on one side. What I'm about to do next, we are going to do probably like 20 times throughout the course in various chapters. And how do we get our two L's down to a single L so we can solve for a single variable? And the way you do it is fairly simple, and that's factoring. Take the L out. And then what that allows us to do is just divide by the expression, and you're good. It will pop up lots of times, and I'll probably say to you guys, hey, how do we get the two L's down to one L, or whatever the variable would be and whatever the problem would be? And we're going to keep drilling this until you guys are like, oh yeah, I recognize that, this is how I do it. And then, of course, after a few chapters, or maybe just a chapter, you'll just do it naturally. So the idea would be divide both sides by, and there you go. So the idea is to get there quickest and smoothest, isolate the variable. Okay, and that's it for 1.5 day 1.